guys, right triangle trig, angles of depression and elevation. So you want to go ahead and locate that for me real quick. And honest to goodness, the goal for this lesson, see some of you moving back now, awesome. The goal for this lesson is to use angles of depression and elevation to either find a missing angle or find a missing side. And often, the topic we address in this section is what we call indirect measurement. Because sometimes you can't measure things directly. Let's say you were just kind of going downtown for a little day trip and you kind of roughly wanted to know, how tall the U.S. Steel building was. Well, it's not like you're going to bust out a ruler and go measure that thing. Although now you can Google it and figure out how tall it is, right? You might consider using an inclinometer and just tracking how far you are away from that tower to figure out the actual height of the tower. So it is actually something that's super useful. If any of you have ever considered going on, I know like Kennywood used to do physics day at Kennywood, and you walk around with these like very rudimentary sort of tools like an inclinometer and things like that to figure out the height of certain objects. This lesson perhaps may appeal to you. Before I get too far into it, though, it is important. You're going to want to maybe have your pencil and then maybe another color or pen or something like that handy, because I am going to be underlining and sketching some things today. But to start, I just wanted to not do a formal warm-up, but I wanted to review that, in fact, the word problems, your Sohcahtoa formulas are going to remain the same. So remember that the sine of our angle is always going to be our opposite over our hypotenuse. The cosine of our angle is always going to be your adjacent over your hypotenuse. And then that's your tangent of your angle, is going to be the opposite over your adjacent leg. So these three formulas are still very much what we're going to go ahead and use today. Two key vocabulary terms. It's going to be disappointing because they actually mean the exact same thing, but we're going to treat them like they're two separate vocabulary terms. The first term we have is what we call an angle of elevation. And when I think about the angle of elevation, I honest to goodness think about elevating or an elevator, which basically means, when I elevate my eyes or when I ride in an elevator, I'm usually trying to get up to something, right? So, what I need to tell you, this is our first fill in the blank here. We have the angle, so I'm just going to use an angle symbol there, of elevation. That's your first fill in the blank of the day. Is always measured from the ground up. Or we could say from the horizontal up. Think of it like an elevator that only goes up. Fun fact, it is always inside the triangle. So, in the diagram here at the left, see this theta right here? That marks our angle of elevation. And then we're going to bedazzle this diagram a little bit. So, in the diagram at the left, theta marks our angle of elevation of the top of a tree. You're like, Lucas, where's this tree that you're seeing here? Let me show you. I'm going to draw a tree. It's going to be a red tree. Red oak. Get it? Ha! It's a red oak tree because I'm drawing it in red. I'm really bad at drawing. Like, horrible. I killed that artistic side of my brain with some math. Like, brutalized it. Okay, so what I have here is theta, marking the angle of elevation to the top of a tree as seen from a point on the ground. So if this is you right here, see, look, you look amazing. You've lost like 80 pounds. You're a stick. So there's you standing there, and you're looking up to the top of a tree. That angle, you're elevating your eyes to look to the top of that tree. Right there. You're looking up to see it. Up, so that's your angle of elevation. You must look straight ahead and raise your eyes to see the top of the tree, is what that's saying. So in a word problem, if you see the phrase angle of elevation, you can go ahead and just call that angle right in there your theta value, right inside your triangle. Okay, next up, we have this little thing called the angle of depression. And it's not called that because it's sad. The angle of depression is always outside of our triangle. It is never inside of the triangle. So in our diagram again, here's your theta, off to the left. Do you see how it's outside of the triangle? It marks the angle of depression, so it marks that downward rotation of a boat at sea. Again, you're like, where's a boat? From the top of a lighthouse, you're like, there is no lighthouse. So here's me trying to draw a boat. Oh gosh, okay, here goes. So I'm going to draw a sailboat. That's my sailboat. That's what I got. Some water, make it authentic. I'm really bad at drawing with a stylus, a sailboat. I mean, my drawings this year are like, oh. All right, and then to the top of a lighthouse, right? So here's our lighthouse. Okay, lighthouse. I think they're normally tall. And then don't they like have like, some of those pretty ones have like the stripes going down them. And then there's usually like some kind of deck that you can observe things from. And there's usually a light at the top of a lighthouse that shines light places. That's not shabby, people. So what I'm trying to tell you is if you're standing in that lighthouse, what's going to happen, you're standing here, you have to look down to see that boat. So that angle your eyes makes, that's called our angle of depression. So you can think of the angle of depression in relation to the movement of your eyes. You are standing at the top of the lighthouse and you're looking straight ahead. You must lower or depress your eyes to see the boat in the water. Okay, this is also kind of fun. Throwback to geometry, you know you loved it. Do you know what you have right now? Watch this. So these, my friends, do you remember what these little arrows mean when you see them on lines? See those little green arrows there? Do you remember what those meant? Not the same length. They would be hash marks if they were the same length. They're parallel. Yeah, I heard it back there. Is that you, Michaela? Yeah. Okay, so those lines are now parallel. Okay, wait, it gets better. Hold on. I'm going to get rid of these congruent marks. Okay, those are two parallel lines. All right, here's a throwback term. Ready to go back in time like a couple years? Ah, hold on. Okay. This guy right here, you know what he's called? You have two parallel lines cut by a transversal. Remember that? Your transversal was called T, which makes these angles here alternate interior angles. So as seen in the diagram above, the dark black horizontal lines are parallel. This forms two alternate interior angles, and my friends, alternate interior angles, when they're hanging out on two parallel lines cut by a transversal, they are always equal in measure. So for this reason, the angle of depression is always equal to, so the measure of your angle of depression is always actually equal to the measure of the angle of elevation. So if one's 30, the other's 30. If you don't like working with an angle outside of the triangle, move it inside. If it's weird to you to look at a diagram where your theta is outside of your right triangle, you can just very quickly move that measure to be your angle of elevation inside the triangle. And that's what most of my students are going to do. So the measure of the angle of depression is always the same as the measure of angle of elevation. See these? Angle of elevation, angle of depression, always the same. Your eyeballs will not lie to you. Don't they look like they're the same? They're both like really acute. A little small. They even look the same. That's not lying to you. That's like a real thing. Okay, now we're ready to try this rooted in good definitions. So angle of elevation is, by definition, where'd it go here? It's always inside the triangle. That doesn't help us because A and C were both inside the triangle. and it's measured from the ground up. The ground up. Carry out in action. Ooh. Oh yeah, this was a nice tip. I forgot I included this. Sorry. So, it actually puts it in writing. I forgot to actually type this up. So what can you do with your angle of depression? Well, you have choices. So what do you do with an angle of depression that's outside of our triangle? Option 1, make this a little bigger so you can see. Sorry. Option 1, you know that these two angles here have to form a right angle when you put them together, which means those two angles have to come together to be 90 degrees. So option 1 is to just figure out the difference between 90 degrees and your theta value. So in this case, if this guy here is 35 degrees, well, that means that guy there had to be 55, because 35 plus 55 makes 90. The other option is to just take what you know about that angle that's outside. Sorry, that's pixelating. Take what you know about that angle that's outside of your triangle and bounce it inside. So if this guy up here is 35 degrees, you can also assume that this guy here is 35 degrees. So you can use that angle in two ways. Gives you a little flexibility in your problem solving. We're going to do a couple of examples together, and then what you're going to see is you have 5 practice problems to try with me, and then if you don't finish them, they will be on your own for a little bit of homework tonight. So in example 1, we're going to go ahead. I always, step 1, I draw a picture. So step 1, here in example 1, it says a 12-meter flagpole casts a 9-meter shadow. I'm supposed to find theta, the angle of elevation of the sun. So I'm going to go ahead and draw a flagpole. So let's see here, flagpole, huh? I'm thinking that's a vertical pole. And you might put like a little flag on it. Little red flag, we are North Hills here. So that's a 9, oh no, I'm sorry, that flagpole is 12 meters, so I'm going to label it, it's a 12-meter flagpole. So that thing is 12 meters tall. It casts a 9-meter shadow. Friends, shadows are on the ground. So we have a 9-meter shadow. That seems like something that wouldn't need to be stated, but you would be surprised where I have people drawing shadows sometimes. They'll like draw them as a hypotenuse. I'm like, I don't know shadows that like necessarily do that. So you have a 12-meter flagpole and a 9-meter shadow. And then do you see how this forms a right angle? And I'm going to have a hypotenuse that comes down. My people, when you draw your picture, it must be a right triangle, because we are studying right triangle trig. Everybody have their drawings down? Okay, wait, I'm not completely done labeling this thing yet. It does say find theta, the angle of elevation of the sun. So think back to our vocabulary. I'm going to call this triangle A, B, C for discussion. So B is our right angle, that's 90 degrees. Can anybody tell me which angle would be theta, our angle of elevation of the sun? Is it A or is it C? Let's take a vote. Who says our angle of elevation is C? A couple of you do? Who, yeah, a couple more? Who says the angle of elevation is angle A? Okay, okay. So a couple of you also think that it is angle A. So let's discuss. So where's our ground here? Our ground is right here. So the ground up is angle C. So our theta gets plopped right in there. And they want me to find that angle. That's like our x. Okay, if you put a theta there, remember our rule for taking notes in class. What goes on the smartboard must go in your notes. And then if you don't understand it, you should not write it down. Does everybody see why we put a theta right there? Because by definition, our angle of elevation Both of these angles are drawn from a horizontal line. Wow. Sorry, I like to explain things. I think that's why I became a teacher. See this like angle, or this angle theta that we just drew in here? All of our angles have to be connected to the horizontal line. Horizontal lines are lines that go straight across. If you would have selected angle A, that's touching a vertical line. So that's never going to be an angle of depression or elevation. Always has to touch our horizontal line. I kid you not. Okay, now we get to do what we did yesterday. So our goal yesterday, the day before, was to solve for a missing angle. So step 1 is we draw a picture and we label it. Step 2, we want to decide Sohcahtoa. So which of those 3 ratios is going to help me solve for theta like you did in your homework? Go ahead, Michaela. Look. I hear cosine, I hear tangent. What do you think, Lexi? I agree, tangent. So tangent, oh man, I should have grabbed my calculator. Tangent of theta, because I don't know what that is going to be equal to the ratio of my opposite side, so that's all the way across, over my adjacent side, which is 9. And it would be nice if I could just divide both sides by tan, but I can't do that. So we tan inverse on this side. And when I do to one side of an equal sign, I must do to another. So I got to do tan inverse of 12 over 9. I'm going to need some help. Tan inverse of 12 over 9. Oh, when I did this one, no, let's see here. What'd you guys get? You know, that's what I got too. Awesome. I got about 53.1 degrees. Questions about that? They may not get 53.1, not know what they did wrong. Okay, let's try it again. And then I'm going to cut you loose, I think. Example dose. This time around, we have an airplane flying at a height of 2 miles above the ground. The distance along the ground from the airplane to the airport is 5 miles. What is the angle of depression from the airplane to the airport? So we're going to solve for an angle again. Step 1, I draw a picture of, oh gosh, an airplane. So there's the tail, there's some wings. That's not bad. Maybe a little window for the pilot to see out of. So this thing's flying 2 miles above the ground. 2 miles. The distance along the ground, so I'm going to draw the ground because it told me to, from the airplane to the airport is 5 miles. And there's my right angle right there. I'm always drawing a right triangle because that is the shape we're studying right now. And what they're asking me to think about is the angle of depression from the airplane to my airport. We're going to call that my airport, AP airport. So the angle of depression, by definition, has to be an angle that's outside of my triangle. So it measures from the horizontal down. So it's like the pilot in this little airplane right here. It's like that pilot is looking down. So here's my pilot sitting in the airplane, and he's looking down at this airport down here. He has to kind of depress his eyes to look at that airport. That angle out there is less than helpful. It looks like it's just hanging out in midair. So what do? I have 2 options. And I'm going to exercise that second one we talked about. I'm going to take that theta and I'm going to shove it right in there. Because I know that those 2 angles are the same. And now I can go ahead and figure out that angle measure. so step 1, I draw a picture. Step 2, I gotta decide Sohcahtoa or Toa. What do you think? I agree. Tan. So tan theta equals our opposite over our adjacent. Now I'd love to divide both sides by tan, but we're not allowed to do that. So I got tan inverse on the left side, tan inverse on the right side. And then I solve for theta with my calculadora. What'd you guys get? I know what I got. What'd you get, Molly? That's what I got too. Awesome. Woo! So step 1, I drew a picture. Step 2, I did Sohcahtoa. Step 3, I used my Sohcahtoa ratio to solve for the missing quantity. Sometimes it's a side, sometimes it's an angle. We are doing that jam right there where you got to do the inverse function. So I did not set up a proportion to solve for a missing angle. Yes, Michaela, what can I do for you? All right. This is where you get to try. Okay, wait a second. Fun fact, the hardest part of this lesson is drawing the picture. So what I want you to do, we're just going to focus on these first 2 problems first. I want you to read them and just draw your picture so that we can troubleshoot that. I want to see how that's going for you guys. So please take a second, read over practice problem 1 and practice problem 2. I just want you to draw your picture. All right. I'm going to come around and start taking a look at that homework from last night too. Okay, so that is how you set up practice problem 1 and practice problem 2. Any questions about either of those? The picture or why we chose tangent for practice problem 1 or sine for practice problem 2? Okay, now you get into the step 3 where you solve for the missing quantity. And my recommendation is always to just solve the resulting proportion by placing your trig function over 1. Again, this is for when we actually already know the angle measures. If we don't know the angle measures, okay, you do. Perfect, yes. So, yeah, just to summarize what I heard from you, that's spot on. That's absolutely correct. So here is our angle measure, and we're always using this as our point of reference. So in this case, the x is the opposite side. It's all the way across the triangle. And then this 50 is what we call adjacent to that acute angle measure, because adjacent just means next to. So, side measures, I always use x or y. Theta is reserved for angles. Is that what you were asking? Did I understand that correctly? The angle measurement of theta, you judge it on theta, not x. Correct. Correct. We always go from the angle. So here I had 35 degrees. I had the opposite side was my x, and then they gave me information about the hypotenuse. The hypotenuse, my students will get mixed up because they're like, hey, that's adjacent to your angle too. Yes, but more importantly, it is our longest side and across from our right angle. So that idea trumps the fact that it's adjacent. It's very special, it's very big, so we call that our hypotenuse. So I had opposite over hypotenuse in this case, and that's so, opposite over hypotenuse. Good question, thank you. All right, and then we solve. So when I solved the first one, I did basically 50 times the tan, times the tan of 71.5 in my calculator, and I got my x value. So x for this one ended up being, it's a big tree, I got 149.4 feet. And then this guy here, again, doing my cross products, I have 25 times the sine of 35 degrees And that's equal to x times 1, which is x. And when I keyed that guy in my calculator, I got about 14.3 meters. Don't forget your units. No naked numbers, right? It's one of my rules up there. So don't forget your units at the end. These are, this type of trigonometry is actually the most common type of trigonometry on your SAT. Right triangle trig. So if some of you are still hunting down a good score on that, right triangle trig is very prevalent. Your mission for tonight was to kind of carry on through the 5 practice problems that are there for you.